Before we start the webinar, folks. Just wanted to make sure Shantanu is connected. Welcome. Welcome. Shantanu, you ready to go?
Yes, I'm ready.
Awesome. Just to start off, my name is Rich Friedman from Redline 13. We're continuing webinar series with a whole lot of interesting folks out in the community. Today, Shantanu Sarkar, who is an industry expert. If you haven't read his blog, I would highly suggest it. But to start that off, Shantanu, maybe you can give us an introduction of yourself, and then we can dive into performance monitoring.
Hi everyone, I'm Shantanu Sarkar, currently working in Luxor, Poland. My current work location is with UBS, it's a Swiss bank, and I am working there as a performance developer, as a team lead. So I used to manage their service delivery whole product line for US and UK line. So mainly based on investment banking sector. So the whole lot of blogs that you find in my blogs, this all will be from my experiences and with some of examples. And today I will be expressing small part of those from my experiences regarding how much it is important to have monitoring while doing performance testing.
Great. And we had talked. Tell us a little bit about your definition of performance engineering and the things that make it up.
So let's get started with initially in our industry, when we start our performance activity, we actually start in a very reactive basis. We start with performance testing. But if you think about performance of the application itself, it is a fully engineering process. That means there will be requirements, there will be proper way of plotting your performance goals, then there will be performance testing, there will be performance analysis, debugging, optimizations, and then validity. So though we start performance from the testing, this testing activity actually helps in two stages. One stage to find performance bugs, and second stage to validate performance. So the testers who started their career from performance testing, they need to grow up themselves to more of engineering level, where they can not only test and validate the application by the performance perspectives, they also can help the whole team to actually orchestrate or implode those performance engineering in the product built from the beginning, so that in the end, the product that they are working on can be make performance-wise better. So that part is a kind of, I should say, performance testing is kind of a subset of performance engineering. And this performance engineering, if you look at all of those parts, we can actually see, first of all, we need to know about the architecture itself. What is the performance engineering part? So in the performance engineering, the architectures, based on the architectures, we define all of the components, like if traditional architectures which have client-server models. So that means there will be some testing with client-side performance testing, server-side performance testing. Then there will be architectural-based monitoring, like you have to monitor the client where people are accessing applications. You have to monitor the servers where the server is hosted. You have to monitor the backend infrastructure where one server is connected to distributed servers. So that means in the whole full backend infrastructure systems, the architecture will define where there should be monitoring. And after that, when you want to know more information based on the performance test results, then we will do the profiling part. So we do profiling based on applications, based on application part moduling, and based on how user are using, and this whole information will be tied together and make a story for the product, which will define and show what can be the possible performance problems, or if there is existing performance problems. Because if you are telling about like problems or bugs, that means you must have the requirements from the beginning. So if you have the performance requirements in place properly, you can define those performance observation as a performance bugs, and then it can be resolved as a standard bug solving procedure. But again, the performance engineering is more about the software architecture itself rather than only functional test, because in a traditional QA method we used to do only functional testing, whereas performance test and performance engineering is more rely with application architectures and application how it is deployed on that sense.
Yep, and I know you actually have a good, really cool view. I'm going to go to about how you dive in, kind of built your own mind map. Tell us a little bit about what you've built, and maybe even drill into each of these pieces. How you think through load testing, performance testing.
Yep. As you can see, it is a kind of simple mind map way how we think about performance testing. We are ready for the performance test. So from the beginning, if we think about like when you get for a standard testing process, like let's say functional test, in the beginning they used to get the requirements. But most of the cases in performance testing world, as long as I have seen, there are hardly any concrete requirements. Most of the cases, it is a kind of business guys want to do some performance test, or the team want to do performance test, but they do not know. But for beginning of a performance testing, you should know what actually you need to do or what you are going to do. So that is why performance testing from the beginning, first of all, you need to do what is the performance requirements based on your request, based on your user. You need to define how user going to interact with the system. You need to define what are the steps user used to do, what are the important scenarios user used to perform. Then you define the cases, you sample and break down the scenarios into category group, make a priority with the business team as well as development team who knows more application in better, and then define what are the things you need to do for, what are the scenarios you need to cover for performance test. So from the performance requirements, that is the scenario part. The second part will be the test case making based on the tool. Now the test tool, in the test tool section, the part I had only mentioned, you can, this mind map I have provided the link also, you can drill down and go to deeper. Let me give you just an overview regarding the test tool. Based on the requirements and application architecture itself, you need to define what tools you have. Like usually I prefer like 4 kind of things. First of all, does this tool support our current applications? Like is it be able to test? Can we test it over here? Like do we know how, like how we debug those things in the test tool so that we can get the whole informations. So how we obtain the results so that we can format based on our requirements, and then how we can able to maintain the test cases to easy to do it, and then how to create test cases, and how to create test cases based on the person who is actually writing the scripts, his skills. So that means the people who is in your team, his skill set is also important key area of this particular context. So that means when you say yes, I can write the test case, you know, and I can choose this test tool, maybe JMeter, maybe load runner, or maybe Gatling or Grinder, whatever tool you choose. But you should know about this main part that you can apply your requirement in your application, in your test tools, so that you can be written. In here, sometimes people used to like underestimate regarding test case maintenance, because let's say if you are maintaining in JMeter or load runner, this maintenance part is very important, because if you are giving the control to the another person who is going to take over your task, it is very important to make test cases more I should say understandable way or efficiently, so that you can actually go through all of this.
Yep.
So this is one of the kind of key part, and for the reporting, it is another important part. Let me give through only 1 or 2 lines. For the test reporting, actually it is an essential part of performance engineering. Why? Because test reports will have multiple audience, like stakeholder reports, like QA or development team reports, or like your, or let's say, usability reports. It can be a usability part also. So this test reporting will also be kind of different way of I should say representing the same skills, different formats, like what are the charts you need to make, like for some best cases examples I can say, for business guys I always keep response time over time, response time over threads, response time over individual scenarios, and I do for developers. I always add more throughput over time and throughput over user, because when you are talking to your development team, they will they want to know more about what they need to do, how many requests per second is having, does they need more capacity to increase, does they need more power to give to their servers, or does they need to optimize their application itself. So this reporting part is very important. Most of the cases, what happens, like junior testers, they used to kind of give everything to everyone, and that makes the reporting actually not useful, because you cannot make it is important to the audience to understand the reports.
Yeah, and for folks that want to see it, we'll make the links that are in the presentation available. But Shantanu's mind map of how to walk through this process, as you can see, here's a live version. We can click through each of the aspects of it for each piece and drill into it. And he's done this amazing job of blowing out everything he's thought through and all the experiences he has built into this. So it's really good. And what section do you want to talk about next? We talked about performance testing and the report. You talked a little bit about requirements. Any other pieces you want to talk about in the mind map?
No, let's go to from the mind map. Actually, I completed for test environment, test case, test tool, and reporting. Yep. And
Yep.
for the folks who are actually write the test cases, you can see the correlation also, because there is another mind map for correlation also. You can see. So this will be more helpful for you to understand regarding how you can find out the difficulties inside correlation parameters and what to check on, because usually these are kind of what it call all type of variants, and you can actually check individual variants that based on your application infrastructure. For example, you can see like what are the static parameters, environment parameters. Environment parameters, you can see like client side parameter is going like client server, the browser as a names, even what authentication person is giving authentication tokens over there. So there's a large number of parameters I listed over here. So in case when you're doing correlation, you can actually check out those types and try to see which parameters are changing. Like this is the rule of thumbs. What parameters you need to change? The parameters which are changing based on your user trends, based on your two recordings. Then you can actually correlate those parameters based on the changes, so that it can be more effective and you can run on multiple users. Because on a client server communication, there are large number of parameters based on your securities and based on the application deployment models. So Rich, would you please go to slide 4, performance testing at a glance.
This slide or performance testing?
Slide 4, performance testing at a glance. Yes.
This one? Yeah.
Performance testing at the next slide next. Yes. So in this performance testing at a glance, it is very important to know that this performance requirement part I explained. So you can check, and if anyone has any questions regarding individual cases or scenarios for the application itself, you can actually define those. So in here, key important thing is user scenarios, user stories for the performance. So why it is important? Most of us nowadays working with agile methods, but as you know, and sometimes you may see, like performance testing does not go that much with agile methodologies. Like most of them, they are on waterfalls, but actually it is not. You can actually define your performance requirement, inbuilt your development process, so that you make it like as agile. So if you define your performance scenarios with performance stories from the beginning, so that you can inbuild your performance test in your development code, like from unit test to integration test and to JMeter request sending test, or any performance tool based request sending test from the beginning of the application, then you can actually define our target wise performance test from the beginning. Rich, can you go to next slide?
Yep.
Yep. So Next slide, it's about writing scripts. Writing scripts, I do not want to get details, but let me give like 1 minute clear through. The performance writing scripts, one of the key skill for a performance engineer. It should be a key skill. Writing performance scripts just like as writing code. So that means the all type of code measurements, like how you optimize the code, how you optimize efficient the code, having less memory, less CPU uses, easy to manage, easy to understand, all of the things applying for a performance test scripts. So that is why it is very, very important. It is very also important to make a proper correlation data with defining all SLAs implementation inside of your test case, like how many, what are the response time, what are the data validations, what are the throughput requirements, how you randomize your user scenarios, user support, concurrency users, how you implement your business scenarios into technical test steps, how you make your individual request steps into business transactions representation so that business guys also can understand. So these all organization part is one of the key skill for a performance in a tester who write the scripts. No matter what tool you use, it can use LoadRunner, you can use JMeter, or you can use any of the tools, but those are one of the very important part. And another thing that is nowadays is more like kind of added value with for the tool foundation, that is supporting continuous delivery or continuous integration, so that you write the scripts in a proper, I should say, flexible way, so that there are more parameters and more way of customization, so that in runtime we only change the build scripts, not the test scripts itself, so that you make test scripts for once and it can be runnable for each scenario for all life cycle of the particular product.
That's great. In looking at this, is there any specific metric in all the tests that you've done? What metric do you look at more often? What's usually one of the more important metrics you look at?
As a part of a technical team lead, I always see about how many requests per second and how many error rate per second. It can be rate per second as well as rate per user, because what it happens for business applications, like we are in banking sector, so these are more about how much tolerance application it is. So if error comes, let's say 100 concurrent users, so we have to point it out and make a figure out with our developers, like how they can increase this number. So request per second is important for the server capacity, so that you can go to the ops team and tell them, okay, increase our server limits. And error rates, we go to our development team, tell them about, guys, can you make it more less errors and improve our application itself.
Makes sense. Makes sense. So why don't we shift a little bit? You were going to talk a little bit about now as we go from the mind map of how you do it. I know we're going to get into a little bit of actual analysis and some of the tools you use for correlation. So why don't you start us off on there?
So regarding correlations and all other stuffs, the initial thing I should say, like the main basic of a performance engineer who understands the performance of an application, he need to know about application architecture. It should be, is a must needed. If you are beginning at the beginning in the team, you need to know how application actually working, to know about the performance itself. I give an example of a simple client server applications where you can see from the client they are requesting server, and then server actually providing the answers by the response. Now initially we always think about, okay, there is a server, we host Apache or any IIS, and then we get it. Actually, as a performance engineer, it is not like as a simple developer. You need to know how, let's say for example, your Java application, how it is working. It is hosted on a Java J2EE host, like any application server, maybe Apache, Apache Tomcat, or WebSphere or WebLogic, any server. Now you need to know about how the server is actually working, how many requests per second server can provide, how server will give you the logs so that you can debug a problem in the server, how to configure server properly. So it is about server, how application is there. Nowadays applications are used to be like 2-tier, 3-tier, or even multiple tier based on based on the application architecture, like enterprise service bus. Like there is a bus in the backend. So what it happens, you need to know about how the server is actually working in the back, like where it is going to database, how it is interacting with web services. because nowadays we are in the mobile world, where our mobile apps are directly communicating with direct web services. In the web service, web service is hosted in some servers, and that server is actually going back and asking to different other servers. For the
Sure.
banks, they are always kind of a enterprise service bus where there are multiple services are hosted, and all requests are going over there and processed via message brokers. So you need to
Once
know
you
about
know
this.
once you know all these pieces, once you have all these pieces, so it's really important to lay out your architecture. But what are
Yes.
the things that you're going to monitor? Because there's client, there's server, there's database. What are the different things that you monitor or you think are required monitoring?
So for the record monitoring, if you go here, you can see actually I put only the basic one. Like as a new person, you can actually get this. Record monitoring is full implementation of your performance requirements, because from the performance requirements you extract scenario and make performance test case. But for monitoring, you need to extract what are the areas your application touches for processing an individual request. For example, let's say your application is doing some login. So for the login, let's say your application is doing login. So that means it will go to the browser. From the browser, it will go to the server. So that means you need to first have monitor for the client. If you are care about client-side performance test, then go back to the server. The request has been processed to the application server, to the backend database. So you have to monitor the application server itself, as well as application server host PC. So that is server host. From there, you go back to database, have some authentication, and get the response, generate the authentication token, and get back to the client itself. So in the database end, you need to monitor what is the database activity, and what is how the database actually process this, like what query they called and what response they get. Now this is kind of very overview. Now if we are thinking about how much monitoring is enough so that we can actually make it more useful. That is actually based on your whole requirement implementation. Let's say your application is in development phase, so you need to have a detailed monitoring. So in that case, I should say initial monitoring is CPU resource monitoring, CPU, memory, network IO, disk IO, even CPU like processing queue length that is happening in application server as well as database server. In the database server, there are disk IO also important, and another one is input output per second, so how many requests has been processed in the database servers. So all of these items you have to monitor for individual server, application server, database server, even when you have business logic server separately, like we have in most of the business domain for banking or any other business specific areas. So the business domain server, they are also doing separately with this. So you need to make all of this in a same I should say in a round, or we call it in whole arrangement, so that you can track from the beginning to the end, and you define your monitoring based on what are the things you need to get. And another key important things, most of the servers and most of the application servers nowadays, my application server and database server, where there is application managing your request, always maintain some minimal basic traceability, like traceability via logging, like it will provide logs and you can actually see it. Traceability provide their instrumentation tools, like application server, if it is built on Java, then you can have Java application monitoring and profiling tool supported. For Oracle, as a database examples, they also have this monitoring and profiling tool inbuilt of their application. So you need to turn on those to have the record monitoring.
Yeah, so there's so many different pieces in there, and you do a good job here of laying out all of the from client side to the server side and different pieces. And you had talked about, you separate out when you talk about in your blog about performance engineering, top down and bottom up. Can you talk a little bit about that?
Yep. So regarding top-down and bottom-up approach, this is a very traditional approach for how you do analysis of your performance results. Like let's say in that stage, previously we know how to write this case, how we test this, how we test our application, and then how we monitor our application. Now we are making all of them together to actually analyze our performance stage. So that is why it is important to know like how to do performance analysis, top-down approach. So you can see I start from the beginning. At this point, you know the measurement from the performance test, you know the test. So you start the monitoring your infrastructure, operating system and network infrastructure. Then you get into monitoring application. This application means your application running on some individual host or any application server. So you are trying to monitor your application server itself, and then you are monitoring dependent applications, like what are the applications is supporting your main applications, like it can be web services, database, and third-party external dependencies all together. So this is the monitoring cases. I also you can see from the image I give a small tools for APM tools. I will give details in the later on. APM tools, application performance monitoring tools, is a set of tools which actually have all of the monitoring in one place to make it more easy. That's why most of the APMs are actually paid solution. So they give us a service to have monitoring all together. So we have done monitoring. Now we are actually break down small request by request processing. So what it happens if you know like how to debug your applications, you can actually know these things very well. How you know this? Let's say for a login scenario I was telling in the beginning. Let's say in the login scenario, when you click the login, actually user actually sees it is a one click, but it happens large number of requests in the backend. So this profile or instrumentation application part actually divide each and every request separately and take care, measure each and every one separately. So that is why we will be looking at which part of our request actually getting high peak, why you are facing large amount of response time, which may be defined as a bug. Then we actually make individual request. It can be individual request based on application code, based on individual class if it is Java or .NET, or even individual method. And then we have to tune that individual code block or class or method, and then we need to provide a validation for that. So in here we started with performance test. We test in the start, and we are actually we did monitoring and we put into a validation state. So that means retest should be necessary over here with the same conditions. And then we have to go through look to our requirements that okay, this much optimization, is it necessary, is it okay, is it enough? Then we have to go to the end. In this decision making part, is it necessary? That part is very important for the stakeholders, because performance sometimes you will see it is a never ending. So you can optimize a lot of part, you can change architecture, you can change, optimize all of the things. So in this satisfactory decision making, you have to come up with what are the priority we have. Like let's for example, there was one of our web service which was giving, let's say, 25 users. It started the error, but we need to have we had 20 users concurrently. 25 we do not have any problem, but we were expecting in a high peak log there will be 50 to 55 users. So we can actually optimize this individual web service for 100 concurrent user or even 200 concurrent user, but we stop ourselves up to 20, up to 25 to jump up to 50 with like 2x scalability measurements, and after that we stop optimization so that we do not over cost our whole activity.
So Shantanu, and we went pretty deep in that. So at this piece, we're talking about the top down is I'm going to start on my application, I'm going to use APM, and I'm going to drill into the details. Where bottom up is at the resource level, the CPU, the memory, the I/O, the network, right? When I'm looking at the details and the tuning of the optimization of my hardware, my JVM, is that, am I getting that's what the difference is between these two?
Exactly. The bottom up, if you go to the next slide, is bottom up. Next slide. In the next slide, you will actually see after top down scenario, when we are okay with now we do not know, we cannot change the code. We have to optimize our whole environment and configuration so that this individual application on this specific host work properly. That part is come with bottom-up approaches. So where we are optimizing parameters, runtime parameters, optimizing resources, optimizing request tracking, optimizing settings, all of the infrastructure as well as supporting things that an application host is covering. That is our bottom-up analysis. Bottom-up analysis is very useful when, let's say, you are a third-party vendor. You do not have access to the code, so you need to improve the performance. So you will do with the bottom-up approach. That is one of the key things for like performance test service providers. So who are providing performance test, and they can always do that. And you can always do this bottom-up analysis when you do not have access to the code. You can do a, let's say you start with the requirements, you do the performance test, you have basic monitoring, and then you can do the bottom-up analysis and improve the system and then retest. So it is much faster process, and you need less I should say technical code knowledge, because you do not need to go through the code itself. So you can do it like a kind of a third-party service. But for top-down, you must have kind of access to the code.
Why don't we switch gears a little bit, because I think that makes a lot of sense between top-down application, bottom-up hardware, JVM. Why don't we switch gears a little bit, and because you covered so much in there, maybe give everybody a bit of an overview of some of the tools that you use from client side that matched all the stuff you've just been talking about.
Okay. So for the client side monitoring, that is a very good tool. Do you have can you share your Google Chrome?
Sure. You want me to go to that site?
Yes, Google Chrome, and I'm giving you one link. There is a tool I always use that is called Performance Analyzer. Go to Chrome Store and type Performance Analyzer. Let me give you the link.
Sure. So, and there's a lot of different tools that get used, and we'll bring that up in a minute as well. Let's go back into the slides, and we'll bring that up in a little bit.
So, by the way, this client-side monitoring, let me start with some small summary. Why client-side monitoring is very, very important. Like 3 or 4 years ago, if you ask me like how you define client-side monitoring, I would say it is an optional part, or like optional testing, part of testing I should say. But nowadays it is very, very important to have a client-side monitoring. Why? Because our clients, our application has become rich internet applications, and as well as all of them, most of them are kind of become more of Ajax-based requests, like asynchronous JavaScripts. And we have large number of JavaScript framework having all of your maintaining your application inbuilt. So that means not only we are having straightforward request via HTTP GET or POST, we are also having Ajax requested running based on our user events. So we need to monitor those events, how our application actually providing processing the request on the client. So because of that, we must need to monitor our client activity when we are testing web application, which actually has running in the browser. So that is why in this individual link you are looking at the screens, it is contains almost 8 to 10 type of how we can measure this web performance or page performance. So this is one of the helpful for not only developers but also performance engineers. In there are lots of methods. I will explain here only two. One is browser tools. I will be showing you one tool, and browser tool means this is Chrome browser tools, which is also present in Internet Explorer as well as in Firefox built-in, like everyone follows. And second one is browser plugins. That means the same amount of things that we get from browser tools to save our life and time. There are Chrome-based performance analysis tool that is present, which is also in Chrome as well as Firefox. Performance Analyzer. I will give a link in Let me
We'll
give you
look at
the
the
link.
link. We'll look at the link in a little bit. There's so much more to cover. So, and let's share out the list of links and the list of tools afterwards as well. Maybe you can let's drive a little bit more into now the server side monitoring.
Yep. So I give only these two names. I think it is not saved. Rich, can you refresh?
Sure.
Because server side there are two other things.
Yep, that's
Yeah.
all.
There are large number of server side monitoring tools. I put only the tools that I used to use mostly.
Sure.
Top and perf. Top actually support almost all kernels. Perf support I used on 3.19 Linux version, kernel version. So what it does, it actually give us total performance monitoring. Performance monitoring based on resource, based on our application, our process, our individual application server, database server. These are monitoring based on this perf and top. And Windows Task Manager, for the Windows Task Manager, actually nowadays professional guys do not use it. It is a kind of very basic tool.
Yeah.
So from the Task Manager, if you click resource monitoring, you can actually see the perfmon UI. The perfmon UI is very advanced. You can see full detail of performance based on CPU, memory, and networks. So in here, for the memory guys who are more interested for the memory uses, that what I always do, you will see large number of memory types provided for the Windows memory management. So to monitor or to know real memory uses of your operating system, you need to know about how operating system manages your memories. Like if you look at virtual memory uses for individual process, you might be looking at a wrong thing. You need to know about committed memory for an operating system for individual resources. That
Do you
means let's
do you use tools like Graphite as well for server side monitoring?
for the graphite, I use only graphite for showing the monitoring results in UI, like different graphs and show the key part. Like
I use,
whenever
I use
I'm
I use tools like that as well for the server
yes,
side monitoring. So perf and top are great when you're on the box,
yes,
right? Because that you need physical access. But when you're remote and you're performance testing and you're hitting a server farm of 50 servers that are running your web app,
yes.
what other
That,
tools would you use for that?
now that need if you have like multiple host to monitors, you can use tool like we use Prism. Prism is a service based monitoring solution. Like it will have, you can have in different host Prism client, and then you can collect data, and you can show it via graphite this dashboard, and in JSON view you can inbuilt with your own enterprise monitoring dashboards. So
Sure.
in Grafana, in FluxDB, you can integrate all of them together.
And
That
so
is monitoring.
how do you drive into the Java stack? So in the next slide, you have some really cool tools. What are some of the tools you use on the Java side?
For the Java stack, we used to kind of work on like 3 stages. First stage, we used to do only simple monitoring via either JVisual VM or JConsole. You can go to next slide to see the JVisual VM screen. Uh,
I think I'm on that.
JVisual, yep, JVisual VM and JConsole. So if you have JVisual VM, JConsole, and you can see different spikes in your monitoring, like spikes means sawtooth behavior or even repetitive behavior like sine wave, or even you can see if there is out of memory exceptions, you can see tan waves, like it will go up and your JVM crashes. So in that kind of behavior, you need to go for Java Mission Control. Java Mission Control is a very nice tool. You can have flight recordings that will trace down each and every request, and Java Mission Control has the inbuilt tool called JOverflow. JOverflow actually checks and see your memory uses, how much percentage, like how much string, how much collection types, how much how much different type of data types used in JVM stack, so that you can know how much time how much memory actually you need for your individual application, and in which point you are actually leaking the memory. This part is very important and crucial because for all of our web application, we always maintain our session, and this session actually handled single threaded, like single tone or even multi-threaded. like multi-user shared sessions, and even if you have load balancing server, you have multiple sessions shared among different servers. So your JVM, how much usage they used to do, you must need that. This is Visual VMs. Yes.
And yeah, and the next tool you have, which is also related, is the Java Visual VM. Is that in IntelliJ?
No, this is actually IntelliJ. I was profiling my IntelliJ IDE and I
Oh,
did
nice.
this. Okay, so Visual VM actually itself, it is free tool, comes with JDK, and you are looking at thread monitoring part. Thread monitoring is one of the crucial, especially for the thread deadlock condition finding. It is one of the key things when you have a large number of multi-threaded applications which are dependent on individual requests, and if the individual resources, if the resource is locked, you will see deadlock conditions like resource A is waiting for resource B and resource B is waiting for resource A. This deadlock condition actually you can easily find, like from these tools. You take a thread dump, see what resources you found in the thread dump, and you can relate with the thread dump name. Even there are some filters where you can actually show directly, like if there is a deadlock condition is present. The
Gotcha.
commercial tools like JProfiler or YourKit, they actually have this feature on their thread monitoring inbuilt, so that by one or two click you can actually know this information. But in here you need to provide it, take a thread dump, then analyze by yourself. That's different between paid service and free service.
Of course. And so, uh, we're kind of getting close to time. And
Yeah,
there's
go
once again,
first.
in all the webinars we've been doing, there's just so much great content that the community has to offer, and you have blogged about so much of this. Just the mind map alone, once again, is something that we can expand for a long time. Maybe the last thing we get into, because I think it is something that people care quite a bit about and have to spend a lot of time on, is the correlation aspect.
Yeah.
And so why don't you finish up on that topic and give us your thoughts on data on correlation?
Yeah. So data correlation is, I should say, a key thing here. You need to have the imaginary mind. I call it always imagination. This is very important over here, because in not everything you can feed into one screen, or even a giant screen you have. All monitoring you cannot have. But you need to have proper tracking all of those. So first you need to know how request being processed. For number one, you need to know about application architecture. Must you know very well how application is processed. Second part, you need to know, like how many calls. That how many calls means, in uh, when you are monitoring individual request, when you are inside one request, how need to know, like how many calls has been processed for this individual request, like how many times it has been called, then how much time it takes. And the third part is important. You need to know how it is deployed, like is it logically true. Like sometimes you will find when there is a poor way of application architectures. I can give you some examples, like we had application in .NET where our UI was dynamic, and whole UI actually UI style sheet and UI component were stored in our database. So each time the different user comes, based on user permissions, different UI element actually come from the database, compile in application server, and then it becomes shown in the client end. So what it happens, actually initially people thought blame to the actually database itself, it is slow, and people are showing like if we improve database, it will be improved. Yes, it was improved because database call were faster, but the process of showing the dynamic behavior was still long, because the whole component was post compiled. So an user comes, it will compile after the user making decision based on authentication. So this individual case, it is not actually logical for a high performant web application. So what we had to do, we had to detach the database dependency from UI components, and we put all dynamic behavior based on client side. So what it happens, all in the after optimization, all client UI actually come as a JavaScript item in the client side, and in the runtime actually client change the behavior based on the authentication. They do not need to go to the database and then make the whole rendering. They all done in the client side. So this is one of the good example, like how you can analyze and trace down about the every call for your request. Then it becomes like when the test was running, how those are processed, like how many users, when the users were multiple users were hitting the server, you have to monitor that, and how you need to monitor the individual request that you traced down before regarding, yes, this individual request, what is the condition, when it is generating error, why it is generating error, then how much time it takes, what is the capacity, what is the throughput, how is the tolerant, like error rate it comes, you need to check all of those. Number 5 terms is interesting part, you need to know about pattern matching and behavioral matchings. As I have told you before in the beginning, like every performance tester need to be write at very good performance testing scripts. Regular expression is one of the key thing that need to know. The regular expression means matching. So this matching pattern recognition also help to kind of analysis individual test results. So when you are looking at peak number of behaviors like request per second, throughput per second, error rates, you need to know like which way the error comes, when this scenario can be happen, how this will be done. And sixth part is when you have all of these your suspect and what if scenarios in place, like what if it happens, what if this scenario happens, what if this much user comes, what if this server is down, like this kind of what if scenario happens, you need to profile individual request or monitor or individual application tag itself, so that you can get the root cause and go to the developer and tell them, okay guys, here is the problem. I will show you one example with this if we have time.
Yeah. Shantanu, I think I'm going to call you Dr. Shantanu from now on. This is because you're definitely the doctor of this stuff, and it also proves out a point that I think we did a presentation a couple of years ago and talking about that the hardest part of performance testing is exactly this, right? It's finding out the details,
Yeah.
and I think the message today, and I think so. There's still a lot. There's still more content for folks. We'll make the slide deck, if Shantanu is okay with that, public with all the links, and potentially do follow-ups if anybody has any future pieces we can get into, maybe a different webinar, because I think this is good. I think it's a good place to end, because I think it gets into the hard part, and you kind of lay out the steps. And for folks that are in performance testing, they know that these are the steps that you have to walk through. They don't lay out all the details in the sense that it takes a lot of effort and energy. And people getting into performance testing should take note of both everything from your mind map all the way through this. These are steps you have to work through, and it takes practice and experience to really build up. Running the tests to gathering the data and figuring out where the problems are.
Exactly.
So
And by the way,
Shant,
there is one example will be present, like in APM solutions, with APM examples with screenshot, you can actually drill down and see what is exactly problem. Richard, can you show the last slide so that I can show? Okay, so before this slide, actually, this is slide number 26. It will be. In this slide, you can see what I did in different screenshot of the APM with New Relic. This application was built on PHP. They are front-end PHP and JavaScript, and backend was Laravel. Laravel was also a PHP framework, but it is specially designed for more robust and secure framework. They make all web API, like REST APIs based on Laravel. So all communication become Laravel calls, as well as they have mobile applications. So the all actually go to Laravel calls. So Laravel, they are hosted on Red Hat, and the MongoDB and Redis were present. So in here we had a SLA for having all requests should be present, all individual requests should be processed under 200 milliseconds, and some are 100 milliseconds also. So in this image you can see from our when we monitor one of the cloud service from JMeter, that you can see our errors started from where there is 73 user per second. So when we reach up to 73 user, then we have started the error, and error started, we can see the error rate percentage. It is not number of errors, it is percentage of error, that means 0.14%, but it is the beginning of the error. So in that point, what happened in our APM dashboard. In the APM dashboard, we can see our peaks, our rates, and what is the maximum number of like what is the maximum time it taking by whom this login. So when we provide the report to the developer, we tell them this controller, like this controller, actually we know MVC controller. I show the picture also. From the MVC controller, MVC model, you can see the controller actually process the user request that happen in the server. So in this individual controller, this individual method, actually we need to optimize either in the database end or in the application logging procedure agent. So in the end of this our activity, when we come to the developer, like this is the root cause of the problem, we need to optimize 1 or 2 or 5 areas. And when you come up with this, then the developers will be kind of more focused on performance optimization on individual part of their code, which will improve their application performance rather than going through all of this. So that can bring the highest value of a performance engineer in a development team.
Good stuff, Shantanu. Dr. Shantanu, that is. It really is. Really, really a lot of detail, and understand why your blog posts are so detailed, and so many people have come to respect your knowledge in this space. So I want to end the webinar now. Once again, we'll make everything public, share it out externally. Thank everybody for attending. Thank very much to Shantanu for building this information set, providing it, and speaking on it. And we look forward to continued webinars and some new features and products coming out from Redline 13. Thanks, everyone. Thank you, Shantanu.